Hello, everyone. My name is Abdullah Ibrahim from Gurney American University, Faculty of Architecture, North Cyprus. The topic for my study is shading for thermal comfort and energy optimization. I have the table of contents, which includes the introduction, problem definition, aims and objectives of the research, purpose of the research, significance of the research questions, research methodology, and the conclusion. The key terminologies within the frame of the study are Nigeria, which is the context in which the study was carried out, shading in high-rise residential buildings, energy optimization, hot and humid climates, traditional and vernacular architecture. So under the introduction, the world faces challenges of climate change and energy efficiency. Passive shading strategies have become increasingly important in high-rise residential buildings, especially in hot and humid climates. So you might ask why I decided to go for passive shading strategies. Agreed and admitted there are other passive strategies, passive design strategies affiliated with energy efficiency, but I opted for passive shading strategies because they are the most easily retrofitted when it comes to the bulk of existing buildings which have no consideration of energy efficiency. It's also a low-cost form of passive design strategies in the sense that it encompasses households of different status, from the high income to the low income earners. Also, the use of vernacular and traditional buildings can be invaluable for contemporary modern architecture in terms of passive cooling techniques through passive shading. This study explored the implications of passive shading strategies for high-rise residential buildings in hot and humid climates, drawing on lessons from vernacular and traditional buildings within the major ethnicities in Nigeria. The problem statement goes as follows. There's a huge stock of high-rise buildings which do not have energy optimization considerations. The passive shading strategies can reduce heat gain and improve indoor thermal comfort, but their effectiveness depends on various factors such as building orientation, facade designs, and local climatic conditions. Therefore, there's a need to evaluate the performance of different passive shading strategies and configurations in specific contexts. For the research aims and objectives, the aims of the study was creating awareness on towards professionals of the importance of energy optimization, while the objectives were to analyze case studies of vernacular and traditional residential buildings that use passive shading strategies and extract design principles and lessons learned within, to evaluate the performance of these strategies in terms of reducing heat gain and enhancing thermal comfort. Lastly, but not the least, to identify the most suitable passive shading strategies for different contemporary high-rise residential buildings of hot and humid climates within Nigeria. The purpose of the research highlights the effectiveness of passive shading strategies in high-rise residential buildings of hot and humid climates based on lessons learned from vernacular and traditional builders, and also to provide suitable guides for professionals and researchers. The significance of the study is majorly to contribute to sustainable architecture. Afterwards, speaking about the other significance, our passive shading strategies can reduce energy consumption and improve indoor thermal comfort, which is crucial in regions with high temperature and high humidity. The study of vernacular and traditional buildings can provide insight into how local communities have adapted to their environment over time. The research questions that guided this paper were: what are the most effective passive shading strategies for high-rise residential buildings in hot and humid climates based on lessons from vernacular and traditional buildings? How do these strategies perform in terms of reducing heat gain and enhancing thermal comfort? And lastly, what are the implications of these strategies for energy efficiency and indoor thermal comfort? Design methodology speaks about two major components which firstly is the study area which happens to be Nigeria, and then the means for data collection. The means for data collection followed a mixed approach where we have the qualitative methods under which has subjective indicators and quantitative methods which has objective indicators. Other forms for data collection are desktop review of relevant peer-reviewed articles from peer-reviewed journals associated with passive shading strategies by vernacular and traditional builders, field study of the vernacular and traditional buildings in regions within the context of Nigeria to observe design features and shading techniques. There was also case study analysis, which was drawn from the review of relevant literatures associated with the most effective passive shading strategies associated mainly with high-rise residential buildings in hot and humid climates. The case study analysis, the criteria for the case study analysis was governed by picking 5 buildings within the major 5 ethnic groups within Nigeria. The reason for this is because Nigeria is a very vast region with multiple ethnicities, and each of them having distinct architectural features. So having these 5 buildings from different ethnic groups gives us a proper insight in trying to capture the architectural features, and in return having to know the passive shading strategies which were employed within these buildings. After which there was interviews conducted, semi-structured interviews conducted, in which we sorted opinions from professionals such as academicians, architects, and engineers based on the following questions. What is the most effective passive shading strategies for houses in hot and humid climates in terms of reducing the energy demand on energy consumption in contemporary high-rise residential buildings, which can be recalled from vernacular and traditional buildings? Secondly, we sought to know the preferred passive shading strategies that can be developed in the contemporary high-rise residential buildings depending on vernacular and traditional houses. And lastly, we asked for the most adaptive passive shading strategies that can be developed within the contemporary high-rise residential buildings, depending on the vernacular and traditional buildings. In conclusion, the study was expected to prefer sustainable. The study was expected to prefer suitable passive shading strategies for energy optimization in indoor thermal comfort for high-rise residential buildings through providing recommendations for effective passive shading strategies. The research will contribute to low-income households on the subject matter. It will also prove that some ancient passive shading strategies are invaluable. The integration of shading strategies should not compromise other important design considerations such as daylighting, views, acoustics, and aesthetics. Lastly, but not the least, it will provide more information for professionals, government code designers, and also researchers in the future. Thank you.